How do we prove factorization of a cube plus b cube? That is sum of two cubes. This is the shape we get. And let's start it with taking two arbitrary numbers, which is 5 and 3. If it is true for 5 and 3, it will be true for all the numbers. This is how we start, by extracting a cuboid having dimensions 5 plus 3 into 3 into 3. Because we know volume of cuboid is length into width into height. In order to complete the previous shape, we add and subtract a cuboid of side length 5 into 3 into 3 and another on in order to get a side length of 8, and extending the previous shape along its horizontal axis, we get these three volumes, and on adding these three volumes, and blue we represent with minus sign because we are extracting this much volume to complete the previous one, and shifting to the variables we get a cuboid side length a plus b into b square. We complete the previous with the help of two cuboids. One is of side length ab square, second is of side length a square b. Keeping it in order, we get three cuboids having same side length, which is a plus b. On calculating these volumes and adding these volumes, representing blue with the minus symbol, we get factorization of a cube plus b cube, that is a binomial, that is a plus b, into a trinomial, that is a square minus ab plus b square. This is the factorization of sum of two cubes. In second configuration, we extend it along vertical axis on extracting a cuboid having dimensions a plus b into b square, and completing the previous on adding a square b and ab square. That means a into b into b. We get factorization of a cube plus b cube. This is how we did in the first configuration, in which we extend the remaining cube that we obtained on adding and subtracting a b square 5 into 3 into 3, extending along length of the cube. We get a plus b into a square, and subtracting a plus b into ab and getting a factor a plus b common, we get factorization. Here we solve it algebraically, that is product of a binomial with the trinomial. First we multiply a with the each term of second expression, then b with each term of the second expression. Now we multiply a with each term of second expression, that is trinomial, a into a square cube of a into minus ab, that is minus a square b, plus a into b square, that is ab square. In the same way, we multiply b with each term of the trinomial, and we get b a square minus ab square plus cube of b. Now, cancelling like terms having opposite sign, we get sum of two cubes, that is a cube plus b cube. Here's another way to prove the result. On extracting a cuboid and rest of the shape, we divide it into two cuboids, and we know the volume for the cuboid. How to calculate? In first, 2 into 5 into 5. In second, 2 into 3 into 5. Shifting these to the variables a as 5, b as 3, and 2 as a minus b, we get this expression. Now to solve this expression, we get a minus b common from last two terms. Here we get a common from last expression. Second term we have a minus b into a plus b. Now we take a plus b common from these two terms. And here is the result, product of binomial into trinomial, that is factorization of sum of two cubes, geometrically as well as algebraically. Hope you enjoyed the result and you can easily apply in your problems. Thanks for watching.